The ocean ecosystems of the southeastern United States are many and varied. They encompass parts of the Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico. And the Southeast Fisheries Science Center supports them all.
Well, the Southeast region is arguably the most diverse of all the regions. We have 4 main large marine ecosystems, a lot of smaller ecotones that we pay attention to as well.
This is Dive In with NOAA Fisheries. I'm John Sheehan. Today we're continuing our series on the different regional science centers and their scientific surveys with an exploration of the Southeast. Dr. Clay Porch is the director of the Southeast Fisheries Science Center, and we'll talk about his region's many attractions,
more recreational fishing than the rest of the country combined,
and challenges.
The loss of wetlands. We're losing them at a rate of several football fields an hour.
A little later, we'll hear about a specific survey that's vital to managing one of the Southeast's most important stocks, the red snapper, and that also involves physically handling many different kinds of sharks. But first, Dr. Clay Porch, welcome to Dive In with NOAA Fisheries. Thanks so much for coming.
Thank you, John. I'm glad to be here.
Your region spans the Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico. Can you compare and contrast those bodies of water? Are there any similarities, or are they completely different?
They're actually quite different. The Caribbean is pretty much as you would expect. Waters are clear, they're fairly warm, lots of nice picturesque beaches, so it's very attractive for tourism, which is a main economic driver in the Caribbean region. The other thing about the Caribbean that people don't often realize is it's actually fairly densely populated. There are more people living in Puerto Rico and the Virgin Islands than many states. And at the same time, there's a reason those waters are clear. They're clear because there aren't many nutrients, which means the Caribbean is not as productive as some other regions in terms of fisheries. So you have an awful lot of people who like to eat seafood, a lot of tourists who like to eat in restaurants. So there's a lot of pressure on relatively few fish compared to some other regions. If you move over to the Gulf of Mexico, it's a completely different system, a place where it's highly variable, affected by cold fronts coming down from the north, affected by the loop current in the south that brings warmer water. And you have the effects of cold fronts coming through. Massive winter storms that sometimes are fairly intense and kill a lot of the fish that live along the coastal communities, and even things like sea turtles. In fact, we're participants in sea turtle rescue activities where we'll find hundreds and hundreds of turtles that are stunned by the cold, and then we try and warm them up in little safe houses all along the Texas and Louisiana coast. So it's a very productive environment. You have the second largest fishery in the United States there with menhaden, and also a very valuable shrimp fishery. And at the same time, you have arguably the largest recreational fishery in the world. And then we have the Atlantic coast. And that one's really interesting because it's sort of in between the Caribbean and the Gulf. On the southern end, it's more tropical in South Florida. And then as you go further and further north, obviously it's continuous all the way up to Canada. So you start getting cold water species. And you see a real obvious transition from the more tropical species in South Florida as you move up along the coast. Now, our jurisdiction starts from Florida and then ends at the North Carolina-Virginia border. And it used to be that most of our reef fish also stopped around there. But now with climate change and the warming of the oceans, we're starting to see those reef fishes go further and further north. And we're having to collaborate more and more with our partners at the Southeast Fisheries Science Center. So really interesting dynamics that happen there along the Atlantic coast.
In supporting such a wide area that has so much variety, can you give us a sense of the variety of surveys that you conduct to support such a vast area?
Yeah, the Southeast actually has a shorter history than some of the other centers in terms of surveys. Our main surveys started about 30 years ago, and the main ones that we conduct today range from a trawl survey where we basically look at the catch per unit effort of our shrimp fishery, but then we catch a lot of other species and we use those in our stock assessments for things like king mackerel, gray triggerfish, red snapper. And then we conduct visual surveys of a couple different sorts. One of it is based on real-time observations. So we have a diver survey that operates in the clear waters off Florida and in the Caribbean Sea and in partnership with the National Ocean Service. And there you actually have divers go down and count the number of fish they see of each species. And as you can imagine, in the Caribbean and South Florida, you're talking about hundreds of different species they have to know and be able to identify. But in some places, the water's too deep or the dynamics are too strong, the currents are too strong, the weather's not good enough, and we actually use camera systems. So we put cameras down there. They have a special lens that allows them to see almost a 360 view. And then we count fish that way. And then we used automated image analysis to try and process that information more efficiently. We also conduct hook and line type surveys, particularly a long line survey where we laid a mile of long line down in various places along a statistically designed grid. And then we count the fish that we catch on the long line. We take biological samples from them. And that's been particularly important for us for red snapper and several shark species.
We'll be talking about the bottom longline survey in the second part of the show. Stick around.
So we really run the whole range from visual surveys to hook and line surveys to net surveys, trying to get as broad a suite of species that are in our fishery management plans as we can. And also we collect a lot of information like temperature, salinity, and other environmental variables that'll help us better understand the environmental drivers in the ecosystem.
The Southeast has several very specific environmental challenges, one of which being hurricanes and major storms. Can you talk about the ways that your science and your surveys can help in responding to those storms?
Well, fishermen have known for a long time that fish respond to the storms, both before the storm. A lot of times the bite's on ahead of time, so somehow they know one's coming. And then they tend to move away from the storm, either by going a little bit deeper or moving into the shelter of deep into the reefs. And sometimes they actually may move with the storm, but we don't know exactly how that's happening. Fishermen for a long time have argued that the storms actually carry the fish away, but sometimes we'll see the fish move several hundred kilometers, which is farther than the storms could physically move them. So there's something going on in the dynamics that we don't really understand all that well. Now, with our surveys, the challenge is if you really want to understand what's going on in a storm, you have to operate on a time scale that's much shorter than when we normally do our surveys. The impact of a storm is on a much shorter time scale. So if a hurricane rolls in, it's going to displace the fish for a few days, sometimes permanently, but not on the temporal and spatial scales that we can really detect in most of our surveys. Where we see the impact is when we do tagging studies, and if we tag fish in an area, and then a storm comes up, and then we start finding fish that were tagged in that area displaced in another area. One of the studies that we did recently was looking at the distribution of gray triggerfish before and after a storm. We were fortunate to have acoustic tags that were implanted into the gray triggerfish, and they transmit signals to receivers that we've strategically placed along the reef line. And what we found is even fish that were in, say, 90 or 100 feet of water actually started moving deeper as the hurricane approached. So most of the information that we have on the impact of storms is really on those smaller scale studies where we can get data in a time frame that's just before and after the hurricane.
Another unique environmental occurrence in the Southeast are algae blooms, which people don't think much of unless you're living in a Gulf state. Can you describe what they are and why they're so impactful?
Yeah, we have a number of types of algae blooms. Usually they're associated with waters closer to the coast. So, for instance, we get cyanobacteria blooms, that's blue-green algae. And those tend to be on inland waterways and in bays. And basically what happens is you get, particularly after storms, a lot of runoff into these areas where you're washing nutrients and pollutions away from urban zones into the water. You get more agricultural runoff, and that fuels an algae bloom. You have a high level of nutrients. The algae go crazy, much more than you would normally see in the natural environment, and that can lead to fish kills and is certainly rather unsightly. And you can get all kinds of mounds of green slime on shorelines, which obviously homeowners and tourists that are coming to the beach don't want to see that kind of thing. So it's a real problem. And it also actually can lead to accumulations of toxins in fish flesh. So generally we put out advisories where these kind of cyanobacteria blooms not to eat the fish until those have cleared up for some time. But there's other kinds of toxic blooms that lead to shellfish poisoning. And of course, one of the most famous is the red tide. You can see the videos a lot of times after a red tide, and there's just, hundreds of thousands of fish washed up on the beach, from very small bait fish all the way to huge Goliath grouper. And those are the ones that really get as much media attention as anything, but they also affect our federally managed species. There are times where, particularly in 2005, 2014, and then again in 2019, where we had massive red tides that killed a substantial fraction of things like red grouper and gag grouper, and we actually try and account for that in our stock assessments. We have satellite observations, and we take a lot of water tests with a lot of partners, and including working with fishermen themselves who go out and report to us what they're seeing on the water. And we use all that information to try and figure out how intense the red tide is likely to be, and then we incorporate that in our assessments.
Let's switch gears to some of the unique partners and stakeholders that you have down in the Southeast. You mentioned recreational fishing, which is so huge.
Yeah, I mean, there's more recreational fishing in the southeastern United States than the rest of the country combined. And we're not talking about tens of thousands or hundreds of thousands of fishermen, but millions of fishermen. And while each one of them may only take a few fish per year, when you do the math and you multiply millions by a few fish, you're talking about tens of millions of fish. So they have a rather strong impact. And I think what is not always fully appreciated is the recreational fishery has benefited tremendously from technological advances. I mean, just in my lifetime, I used to fish basically by sight, and now we have GPS that can put you right on an individual rock within just a few feet of the place that you mark. And not only that, we can take that same GPS technology, tie it into the autopilot, and we can sit in a strong current without an anchor right on top of a spot, or even hook it up to our fish finder and follow a school around fish. And now I've seen people even using drones and taking fishing lines attached to that and going with their own little, observer platform and finding fish and dropping a line right on top of it. So the fishing power of the recreational fishery has just gone through the roof. So one of the challenges that we have is, how do you manage in a situation where you have so much effort and the capacity to catch fish to a point where they're actually not very common anymore, but you can still catch them because you have such good technology. And so we're really grappling with that in all our councils, the Gulf of Mexico, South Atlantic, and Caribbean.
Yeah. And there's probably pressure from certain states because that's a very big income generator. You've got not just the fishermen, but you've got the charter boats, you've got the supply chains that are supplying the nets and the fishing rods and everything else.
No question about that. Tourism is big in the Southeast, and A lot of people have retired specifically to come here and go fish. And then there's people like me that I just want to get out there and take my family out fishing. So there's no question that's a huge economic driver. It's very important to the states. And there's a lot of people that know their congressman, and they want to make sure that we maintain strong recreational fisheries.
Other partners that you have to keep in mind, your international partners. You touch so many different countries, specifically within the Caribbean. What is that like, having to work across so many boundaries?
It's extremely challenging. In the Caribbean, it's almost impossible. And that's true for a couple reasons. You think about the U.S. Caribbean is the Virgin Islands, St. Thomas, St. Croix, St. John's, and Puerto Rico. That's surrounded by other countries, Cuba on one side, Dominican Republic, Haiti, all the countries of the Lesser Antilles. And the currents in those areas are driven largely by the easterly winds. And there's a lot of recirculation. There's a lot of sharing of fish larvae. So, in other words, the management really ought to be completely interdependent. We should be accounting for the fact that one area might seed another area. But there's two things that mitigate against it. One is just the politics of it. A lot of people, very small area, a lot of people that like to eat fish. And two, a lot of the Caribbean countries don't have the resources to collect the needed data. So it's the status of the stocks in each of the islands is really uncertain. So it's a very difficult situation. And that's just the Caribbean. Now, when you start talking about the International Commission for the Conservation of Atlantic Tuna, now you're in the big time. And there's about 50 countries that are participants of that. We're managing fish that really don't care anything about international boundaries. Bluefin tuna just go wherever they want to go, but everybody is after them. It's one of the most valuable fish out there. And so big science challenge, too, because you're trying to get data from a whole bunch of different countries and mix it all together into a statistical model to figure out how many fish are out there and how many you can take and have enough left over for the future.
Can we turn to climate change? I'm wondering what other big shifts you're seeing in the last 5-10 years as a result of climate change.
Yeah, there's an awful lot to talk about there. And the impacts of climate change are manifest differently in each of our regions. So if you think of the Caribbean, the waters are already warm, so now they're getting warmer. But what that's done is start to stress a lot of the native wildlife there, and in particular corals. So we're seeing increases in bleaching events. We're also starting to see more diseases that are affecting corals, and including even in South Florida, where many corals are almost extinct now. When you look in the Gulf of Mexico, one of the biggest areas where you see the impact of climate change is in the loss of wetlands. So some of it is from sea level rise. Some of it is actually from man-made alterations to the coast, channelizing rivers, putting up seawalls, outright filling in wetlands. But it's a particularly huge concern because the Southeast has more wetlands than most of the rest of the country combined. And we're losing them at a rate of several football fields an hour. I mean, it's astounding how fast we're losing wetlands. Some of that, again, is due to climate change, but some of it is with rising sea levels. But the other thing that's happening with climate change in that area is you're starting to see with the warming, more tropical vegetation starting to take over the marshes that were there before. So in places that normally had like Spartina grass marshes, we're seeing, for instance, black mangroves, normally associated with South Florida, actually colonizing those areas. And then when you go to the east coast of the United States, from Florida all the way up to North Carolina, and of course further north, that's where in some ways the changes in climate are most obvious because you're actually seeing changes in fish distributions. I mentioned earlier that we're starting to find reef fish that used to always be south of the North Carolina-Virginia border. We're starting to find them more and more up to New York. It used to be that you only saw reef fish off New York or Cape Cod in the summertime, and it was just the juveniles that would be carried up there by the Gulf Stream. Now we're starting to see more and more species surviving through the winter there.
Are you seeing other fish that traditionally hadn't been seen in the Southeast moving into the area?
I haven't heard too many cases where Caribbean species that weren't here before are moving into the Southeast. We are seeing more invasive species that may or may not be related to the warming, but one of the most insidious of these has been lionfish. It's an Indo-Pacific predator that has just taken off and is particularly bad in parts of the Gulf of Mexico, where in places around artificial reefs, for example, they almost carpet the bottom, and you just look at this kind of like moving layer on the bottom and you realize it's a bunch of striped lionfish. They're pesky when you're diving because they actually carry toxin in their spines, and if you get stabbed by them, you'll really know it. Fortunately, all you need is some really hot water if you get it in your hands, and it denatures the toxin. But if you don't have something, you're going to be in a world of hurt. But the bigger problem is they're voracious predators. Nothing much eats them, although some sharks and groupers are learning to eat them, but they eat everything.
Is there anything you can do to mitigate them? I mean, are there efforts underway to remove the lionfish?
There are a lot of efforts underway. There's a lot of people who spearfish them. They happen to be pretty tasty to eat. I've eaten them. It's a nice white flaky flesh. The problem is they will also go very deep. I've seen divers spear 100, 200 and around one little artificial reef. The problem is there's lots of places like that are 500 feet deep, and divers can't go there. So the hope is that some of the native predators, Goliath grouper, other groupers, and sharks, moray eels, will increasingly learn to eat them, because they are, after all, a new phenomena. The native wildlife doesn't know what to make of it. But sometimes, and this is what we hope for, the native wildlife will adapt and will have some natural controls, just like they do in the Indo-Pacific. They're not nearly as common there as they are here.
I'd like to close out with your Science Center's experience of the last couple of years, specifically around the pandemic, and what has been the impact on your surveys and on your science?
Well, the impact in 2020 was huge. In fact, we call it the year of no data. We weren't able to get out on our surveys. We weren't able to get out into the fish houses for a large fraction of the year. We couldn't put observers on vessels. So for much of the year, we didn't have any information, but we have made a lot of strides. We were able to get all our surveys accomplished even in 2021. We were able to meet all our major deadlines for providing management advice like stock assessments. We were missing some data to do that, and we had to make some assumptions in some cases, but we were at least able to meet all our obligations. So in 2022, we've been trying to take advantage of other platforms. So we're looking into various use of autonomous vehicles. We want to take more advantage of cooperative research surveys. In fact, we just started one where we actually hire fishermen to go out and lay long lines in deeper water so we can get an index of abundance of things like tilefish and deep water groupers. So as long as we can train them to sample in the ways we need them to sample, then that's a win-win for both sides, right? We get the data we need. They get to be a part of collecting that data and earn a little bit of extra money too.
Well, Dr. Clay Porch, thanks so much for joining us.
Thank you. It's my pleasure.
Dr. Clay Porch is the director of the Southeast Fisheries Science Center. Clay mentioned the center's bottom longline survey that's especially important for red snapper and sharks. I wanted to learn a little more about the survey and why it's critical to keep track of large predators.
In an absence of large predators, you can basically leave the population of smaller predators uncontrolled. If that population just keeps expanding, their prey are clearly going to suffer. So it will, knock the ecosystem out of balance.
That's Dr. William Driggers, who goes by the nickname Trey because, as he explained, he's the third William Driggers. Trey is a research fishery biologist and has been working the bottom longline survey for many years. The ship-based survey goes from Cape Hatteras, North Carolina, down to around West Palm Beach, and in the Gulf of Mexico, from the Dry Tortugas Islands to the Mexico-U.S. border at Brownsville, Texas.
So far, I think we've caught 181 different species, but keep in mind some of those we've just caught one individual of those. That's just the tally of the number of species we caught. But I would say the primary kind of very loyal repeat customers, there's about 20 different species that we collect with regularity. The most abundant would be the Atlantic sharp-nosed shark, which is a small species of shark that anyone that does any type of fishing in the Gulf or off the East Coast is probably very familiar with. And the second most abundant would be black-nosed sharks, which is a little bit larger, but it's also a small species. And then the third most abundant would be red snapper. We also catch yellow-edged grouper, golden tilefish, a number of shark species from deep water species such as Cuban dogfish, gulper sharks, occasionally seven-gill sharks to some of the more common species that people are familiar with from coastal waters such as bull sharks and tiger sharks, black-tip sharks, sandbar sharks, just a whole slew of them.
Sharks are a popular customer.
Yes, for sure. About 50% of our catch is Atlantic sharp-nosed sharks. So like I said, they're very abundant, but yeah, a lot of sharks.
So Trey, what is a long line? Like, what is this thing with all the hooks?
Okay, so long lines are typically a gear used in commercial fisheries. They're frequently used to capture tuna, swordfish. Bottom long lines are what we use, nose fish on the bottom. And so essentially the way those work is that we have what's referred to as a high flyer, which marks the beginning and the end of the gear. So when you begin to deploy the gear, you attach a monofilament line to like a big balloon. It's a lot more sturdy than a balloon, but it's called a polyball. And you throw that off the boat, and the boat starts to pull away, so that line starts trailing out. Then we put a weight on it, which takes it to the bottom, and then we clip gangions. And a gangion is like a potato chip clip, kind of looks like that you clip onto the main line. And on that clip is a 12-foot piece of monofilament, baited with mackerel in our case. So the main line is essentially horizontal. The gangions are vertical. We put out 100 of those, then another weight, cut the line, put a high flyer on it, float away. We do it for 1 hour, and that's for a couple different reasons. One is to minimize any possible injuries to turtles that might be caught, which we catch very infrequently, and also to try to ensure the health of fish that we catch, because many of them, one of our main objectives is to tag and release. So obviously you don't want to tag and release something that's not in good condition. So we try to ensure their safety and health by minimizing that time.
How many fish or sharks per line would you say you catch?
It varies, as you would expect. It can be deflating when you're out in deeper water and you keep pulling in lines with nothing on them and all that. And you're like, man, this is a lot of work. But it's important to know where things aren't as well. As far as the most we've ever caught on one line, the record is 76 sharks on one line. And that is very busy, for sure. Everybody's ready for a little break after that.
Yeah.
Usually, you can expect probably 10 to 20 sharks and snapper, grouper, whatever.
So take me through a day in this survey. What's it like hauling up one of these lines with 100 hooks and who knows how many sharks or other fish attached to it?
Well, we primarily work on the Oregon 2, which is NOAA ship Oregon 2, and that has a crew of, I believe, it's 27 people. If it's not 27, it's right around there, and that includes engineers and stewards and NOAA Corps officers and scientists. It's kind of like a little beehive at first, everybody getting ready, and then we kind of settle into our schedules, which we work 24 hours a day, 2 12-hour shifts. So after we set the gear, like I said earlier, we conduct what's called a CTD, conductivity, temperature, and depth. It's essentially a water profiler. It takes readings from the surface down to the seafloor, and we do that so we can determine, why was this area productive? Why did we catch things here? Why did we not catch things here? Was there something that was different than some ephemeral event like a red tide or hypoxia or something like that, just so we can characterize it? And those data are very important. After that, we generally wait about 15 minutes and then go out and we start hauling back the gear. And then if there's there's any type of fish on there, then we determine how we're going to handle it. If it's a small shark or any type of small fish, really, and by small, I mean 4 feet, 5 feet and less, bring it on board. We have a measuring board. We take up to 4 measurements on each individual, determine its sex if it's a shark, weigh it, and then depending on the species, we'll put a tag in it so we can monitor movement patterns if that fish is recaptured at any point, and then send them on their way. That's for smaller animals. Any large animals, which are always sharks, when we're dealing with the large ones, we have it almost looks like a lift that operates off of a crane that's lowered into the water, and then the guy running the reel, or the person running the reel, I should say, will kind of guide the shark onto we call it the sling, and lift it up so it gets level to where we can work on it. There's at least 2 people controlling the shark, getting a measurement, and then while we're doing that, or getting measurements, I should say, and then while we're doing that, somebody else will slide in. They will take a genetic sample, small piece of fin, and also put on a tag. We remove the hook, lower it back down, and it swims off and hopefully goes and makes baby shark somewhere.
And how fast are you moving through them? Like, how long does it take to say, you first shark on the line, you got to get them up, measure them?
A small shark, I would say by the time we get a hold of the shark, it's probably back off the boat within 1.5 to 2 minutes. If it's a larger shark, depending on how cooperative it is, some of them don't enjoy participating. So it's a little bit more of a challenge. We do go to lengths to try to remove the hook and make certain there's no gear left on any animal. So if, say, for example, one of the more interesting, or one of the species that requires more attention than others are nurse sharks, which is kind of surprising. Everyone kind of thinks of them as this docile creature, where they are amazingly strong, and that's a little bit of a wrestling match. They're not super easy to measure because they curl up and almost like a big thick snake. But it could take, when using the sling, it could take 4 or 5 minutes, probably at most. But we have really good success with getting them off quickly, and we know that we're doing a pretty good job with that, because when we have used satellite tags to monitor them afterwards, everything seems to be doing pretty well.
How many people does it take to wrangle one nurse shark?
Minimum 2. Minimum. But you have your hands full. And one of the and I can assure you we'd put more people on them than that if we had space, but we only have enough, limited space because of the size of the sharks.
Is it one person on the head, the other person working the body?
Yeah, so any time you're dealing with a shark, you have got to know where the business end is and make sure it's pointing away from you. If you're the person on the other end, that can get exciting too. Any of us that has done any type of shark work, I'm sure, has been slapped by a shark, and it's like someone just winding up and dragging some sandpaper across your skin very quickly. So it doesn't take you out of the game, but it's not comfortable. That's for sure.
There's an article on the NOAA Fisheries website that has a lot of pictures of this very survey, and you're in some of them. These pictures look kind of dramatic. You're hauling up sandbar sharks and hammerheads and little tiny dogfish, I think, is in there, but they all look like sharks.
Sure. I don't encourage people to go out and look at those pictures because I have a face for radio, but whatever. But it's nothing that's scary or anything like that. The most terrifying moments I have on there is when the desktop computer that we use says lost network connection. I'm like, then I'm like, well, how are we going to handle this? So we're pretty used to things now, and it's like anything else.
So is it just scientists and crew members on the boat, or can anyone join in?
We do take volunteers, and we have a very active relationship with the Teacher at Sea program, and that's generally a lot of fun. We end up, in some cases, interacting with their classes. In one case, we had a teacher from Oklahoma. We ended up flying up there and meeting her class. We also take students anywhere from undergraduates who are trying to figure out if it's something they want to pursue. We take graduate students who either want to gain some more experience, or we're helping them with collecting samples for their studies. So yeah, we enjoy taking out volunteers, and it's always nice for those of us who go out regularly, because it's like with any job, things can become a little mundane, and you kind of forget, wow, this is really something that I want to do. So we try to take advantage of that. And we also special and neat. I always joke with people like there's somebody in Ohio that would give anything to, trade shoes with us right now. So, yeah, it's something we really like to do and encourage, and we'd be happy to hear from anybody that's interested in going.
Well, Dr. Trey Driggers, thanks so much for talking with us.
It was my pleasure.
Dr. Trey Driggers is a research fishery biologist with the Southeast Fisheries Science Center. I very much recommend checking out the NOAA Fisheries website for the article about the Bottom Longline Survey, featuring pictures of Trey and the sharks. It's worth a look. In our next episode, we'll conclude our series on regional surveys with the U.S. Pacific Islands. I'm John Sheehan, and this has been Dive In with NOAA Fisheries.